Okay, so we should be good right now. 40. Okay, so let's start. Uh, yeah, so today we'll be going over properties of
录不到耳机吗？
properties of Q and I would say R, right? So when I write ABC, you can think of ABC being in Q or R, so the real numbers. So this has a lot of this topic has a lot of relation with Math 120. So if you're interested in that, you should pay more attention. So when I write ABC, I mean like for all ABC and QR. So just so I don't have to write it all the time. So obviously it satisfies the associativity property for addition. So if you add B and C first and then you add A, it's the same as adding A and B first and then C. So you have A plus B is B plus A. Okay, so this just means things are commutative, right? So it means that you could always swap the sums. So, and next we have a zero element. So this is for all A, B, and for all A. And then so the reason I write A1, A2 is because these are the identities for addition, right? So for all A, there exists minus A, such that A plus minus A is 0. So do note minus A is just a symbol, right? It's a symbol for it's the number such that when you add A to it, it's 0. So we're not introducing a minus operation right now. So M1. So again, we have associativity for multiplication, and we obviously have AB is BA for all AB. Right, so what I just wrote here, if you just ignore the top line, like properties of Q and R, this is a property for being a commutative ring if you're into 120. So do note, like, although these properties seem pretty obvious, there are important sets that do have addition and multiplication but don't satisfy this, right? Like an example would be like, I don't know, maybe the set of 2 by 2 matrices, right? Over, I mean, I'm pretty sure you've learned this in Math 3A, but you could certainly add 2 by 2 matrices and multiply 2 by 2 matrices, right? But what you're gonna notice is like M2 is not satisfied, right? Like if I just, probably any example I make up, it will not be satisfied. So, I don't know, 2, 3, 4, 1, right? If you multiply this, what's the first term? It's 1 times 2 plus what? 2 times 4, so that's 10, right? On the other hand, if you swap it, the first term is 2 times 1 plus 3 times 2,
那会儿去 JHU 也不用折腾这一大圈了，哎。
Yes. So you see, like, these two are not equal, right? I mean, the first term is not equal. So you see that matrices, they're not commutative, right? So they don't satisfy. M2 not satisfied. So there are actually other important, I guess, sets that don't satisfy these properties, but in the case we're in, for Q and R, they do. So okay, so anyway, M3. There's an identity element, right? If you multiply it, you get itself. And certainly here for all A negatives, there's the inverse. So this is what makes Q and R a field. There's an inverse. So hopefully you all know for matrices, not everything is invertible, right? You need determinant is non-zero. So, and finally, like right now, I gave you how numbers add and how numbers multiply, right? But there should be a relation between adding and multiplying, and that's called the distributive law. So again, these seem quite obvious, but yeah, so distributive law basically relates addition and multiplication. Okay, so the next important thing about Q and R is that there is an ordering, right? Ordering on Q and R. So hopefully this seems obvious, right? For all AB, either A is less than or equal to B or B less than or equal to A, right? I mean, any two numbers, one of it has to be bigger than or equal to or less than or equal to. And if A is less than or equal to B, B less than or equal to A, then A equals B. So this basically, you just think of it like you can't have a number that's bigger than some other number and also smaller than some other number. So unless it's equal. Bigger than or equal to, I mean, and smaller than or equal to. O3 is the transitive property. So if A is smaller than B, B is smaller than C, then A is smaller than or equal to C. So that should be quite obvious. So, and next, ordering is preserved when you add, right? So certainly, like, if you add C, like, it's still true A plus C is smaller than B plus C. If you started off with A being less than B. And finally, and 0, if A is less than or equal to B and 0 is less than or equal to C, then AC is less than or equal to BC. So we need this C being positive condition, right? I mean, hopefully you all know if you multiply it by a negative sign, the inequality switches, right? Like if 2 is less than 3, negative 2 is bigger than negative 3. So, okay. So some results you can get from fields. So this is the last list I'll write because it seems kind of obvious to everyone. So Q and R. So note up to now, we never really constructed R yet, right? We constructed Z, Q, and then we defined algebraic numbers, right? Like that, we learned like rational zero theorem. So the goal right now is to construct R. But for now, let's, assume we all know what R is. So let's assume, R exists for now. So A plus C is, so basically, there are some operations you can do. You can cancel, right? So is equal to A plus, if A plus C equals B plus P, C, basically you could cancel the C. A times 0 is 0 for all A. So these are stuff that's proved in the book, right? Using the properties I listed above, right? So this one is pretty important for people who want to do, who want to study algebra. So there is no minus operation again, right? So when I write minus A, this is the symbol. It's just a symbol for saying it's the number such that when you add A to it, you get 0. So this is saying the number where if you add A to it, you get 0 times B is just the number where if you add AB to it, you get 0. So there's no minus operation going on here. And similarly, this is true. And finally, we can cancel if C is not 0, right? So I don't think you need to memorize these properties. I mean, it's pretty intuitively obvious, but I do encourage you to try to prove it using just the axioms, listed above, like A1 all the way to DL. So you see some of it is not intuitively off. I mean, it gets pretty hard to prove. You have to think about what to do. So, okay, so more. Let me just say more rules, more results in book. Yeah, there's like a ton of lists. Okay, so here it turns out that if R and Q satisfies all these properties, right? What is the difference between R and Q? Well, one thing we learned back then was Q does not have like stuff like root 2, right? For example, and so on and so forth. So since we all know what R is, right? I mean, similarly, we can easily say Q does not have numbers like pi and E, right? These are like infinite decimals, right? I mean, Q is like of the form like P over like M over N, right? Where M and N are integers. And if you divide out and write the decimal expansion, it either terminates or it repeats, right? So here, these are examples of like things that don't, decimals that don't repeat and don't terminate. So, but we could certainly say we could approximate root 2, right? So hopefully you all know, like for example, I mean, it's like, what is it, 1.41, blah, blah, blah. So like if you just put it in a calculator, so we could certainly approximate this with rational numbers, right? Because our sequence will be 1, 1.4, 1.41, and then whatever is in the decimals going onwards, right? And let me try to remember what pi is, 3.141, 592, something like this, right? That's what pi is. So you can certainly approximate pi this way, right? Each of the numbers I wrote are rational, right? Because this thing is 1 plus 4 over 10. This thing is 1 plus 41 over 100. All of these are rational, right? So basically, you see that although root 2 is not rational, we can approximate it with rational numbers. Like I could find a list of rational numbers that go to root 2. So basically, R is, you know, if you want me to write it in words, include all values rational numbers approach. So if you read the text, you'll notice that like root 2 is like a gap, right? Like you could find infinitely many rationals going to root 2, but you don't hit it, right? So there's like a hole there. So the book refers to like those as like gaps. And basically what we want to do is say, okay, just R is just fill in all the gaps and you get R. So that's the idea. So note the word approach. We need a notion of like, you know, what does approach mean? Yeah, so like what does the word approach mean? And in this case, you know, we need a notion of distance, right? Because we need some way to measure what we mean by we go to some number. So let's define the absolute value. So absolute value of A is A if A is bigger than or equal to 0, and absolute value of A is negative A if A is less than or equal to 0. Okay, so now we could define a distance, right? I might write it like this, right? D of AB. The book writes it like this. I don't think there's gonna be a confusion with this, so I might just use D of AB. We define the distance between A and B to be absolute value of A minus B. So pictorially, what this means is well, what is absolute value of A if you want to write it pictorially? So it's actually the distance from 0 if you were to write it on the number line. So like if you have a number line and like A is here, the distance to 0 is the absolute value, right? So here, it doesn't matter like if it's negative, right? The distance is still preserved, right? So this means, you know, you take the difference and find the distance to 0. So, okay, so this is distance between A and B. Okay, so note let me just write properties of absolute value and distance. So first off, you can show that absolute value of A is bigger than or equal to 0. So so note that here we are using, you know, if you want to prove it formally, you need to use the ordering like O1 to O5, right? To basically, and like you need to use those properties to like prove this. But I mean, it's pretty obvious absolute value of a number is bigger than 0. So, and here absolute value of A and B is, of A times B, I mean, sorry, is absolute value of A times absolute value of B. So hopefully this is also obvious. And third of all, we have absolute value A plus B is less than or equal to absolute value of A plus absolute value of B. So we call this the triangle inequality. So I normally the shorthand, I write it like this. So hopefully you all took, I hope, say multivariable calculus. So if you have a vector like A, B, what is the sum? How would you write the sum, I guess? So maybe I should make it more slanted, since that's how people write vectors. What is the sum? Well, the sum is basically like the diagonal, right? If you all agree with that, it's like the diagonal of the parallelogram. This is A plus B, right? So if you think of the statement, it's basically saying two sides of the triangle is bigger than the third side, right? Because here you have a triangle, right here, right here, right here, right? So the triangle inequality is just using that statement that two sides of a triangle is bigger than the third. So, okay. So next we get that distance also satisfies this. So distance from A to C is less than or equal to distance from A to B plus distance from B to C, right? For all A, B, C. So note, if you just wanted to find a distance between A to C, it doesn't matter what B you choose. Like this is independent of B. So the distance from like 0, if A is 0, C is 100, is less than or equal to distance from like A to like 0 to whatever number you want, like 1 million plus distance of 1 million to 100. So this follows. So let's see this. I mean, it's not that hard. So this will be a trick you need to you want to use sometimes in real analysis. You want to prove something with like another variable, right? So you start here and you're like, okay, I have A and C. How do I introduce B to the equation? Well, I can just subtract and add B, right? So this is a common tool. Another tool is to multiply by 1. So like 1 is the same as like B over B, right? So that's another trick you'll be learning soon. So here, now we use triangle inequality. So my A in this case, I'll underline it once, is this. And then my B is this, right? So I'm using triangle inequality. And this is less than. And this by definition is. Yeah. So you see, so this is like the triangle inequality for distances. Yeah. So, okay. So let me just wrap things up by doing some questions from the text, and then I'll announce like the quiz questions, right? So here, let's go to the liquid text. Okay, so let's do some problems. So I think the most important one is probably 3.5 and 3.8. The others, I think, should be doable. It shouldn't be that hard. So for 3.5, let's assume we have part A, right? I hope it's obvious we all know like if absolute value of B is less than equal to A, like we can get rid of it by doing a double inequality, right? So let's assume we have A, right? So assume we proved that. So assume we proved 3.5A. So let me just write the statement. If I think it's if and only if actually. So absolute value B is less than or equal to A if and only if minus A less than B less than A, right? Okay, so let's try to show 3.5B. So 3.5B is pretty important. It's going to be called the reverse triangle inequality. So this is something you should know. So okay, so here, so because right now, right, for triangle inequality, you have something like A plus B, right? So the question is there some inequality for like A minus B, right? So this problem basically tells you like what the inequality is. So it's basically the absolute, you have two absolute values. So absolute value of A minus absolute value of B is smaller than the difference. So want to show so I guess it's called reverse, right? Because we have A minus B is bigger than something. For triangle inequality, it's A plus B is less than something. Okay, so here we're going to use part A. So let me underline our B in this case. We want to show something. This is so let me double. My A is this whole thing, right? My A is just the whole absolute value of A minus B. And then my B is this thing. So here you're going to get this, basically we want to show using part A, it's negative absolute value A minus B less than or equal to absolute value of A minus absolute value of B less than or equal to, right? So we want to show this. Okay. So let's show one side. So here we're going to use that trick I told you about. So let's start with absolute value of A. And what we're going to do is I need a B. So basically we want to use triangle inequality to prove reverse triangle inequality. So this is the same as A minus B plus B, right? Now I can use triangle inequality on these two terms, right? So this is the actual triangle inequality. And now I subtract absolute value of B to the other side. So we get, if I call this 2 and this is 1, we get 2, right? I basically just showed 2. So how do we get 1? Just start with B instead. So here we're gonna get, it's the same trick, right? We subtract a and add a. Now, yeah, so note this is by triangle inequality, this is less than or equal to absolute value b minus a plus absolute value of a. But note the absolute value of b minus a is just a minus b, right? I mean, because b minus a is the negative of a minus b, right? So absolute value of 1 is 1, absolute value of negative 1 is also 1, right? So we could take out the negative sign. And here, if I subtract a on both sides, I get okay. So this is the part I've been saying. So we can divide by a negative sign, right? So, but when we divide by a negative sign, we have to swap the symbol. So, right. So, oh, sorry, there should be a negative here. So here we proved 1. And then we're done. Is this my mic or? Yeah, sorry if it's my mic. So, okay. So here we basically proved the result, right? We proved reverse triangle inequality. So this is something you'll use in the future. You know, if you ever encounter something minus something, right? If it's a plus sign, then it's easy. It's just triangle inequality. So okay, so let's do one more. So let's do 3.8, right? So it's saying let A, B be an R. Show if A is less than or equal to B1 for every B1 greater than B, then A is less than or equal to B. So this intuitively seems obvious, right? If A is for every, so it's saying for any number bigger than B, if A is smaller than it, then A is also smaller than B, smaller than or equal to. So let's show, so this is an example of maybe we could try proving by contradiction, right? So let me just write it first. Let A, B be an R. So show if A is less than or equal to B1 for all B1 bigger than B. So this should be a B1 here. Hopefully you all see that. Then A is smaller than or equal to B, right? Okay. How are we going to approach this? So let's assume by contradiction A is bigger than B, right? Okay, so I'm going to start asking a question now. So what can we say about A plus B over 2? So is this bigger than, equal to, or less than B? What can you tell me about this? Can anyone respond? So what do you all think? So here we're assuming A is bigger than B. So bigger. Yeah, it should be bigger, right? Because this, if we assume this, right, then this is bigger than B plus B over 2, right? Because A is bigger than B. And this is 2B, so this is just B, right? So certainly a plus b over 2 is bigger than b. So, but now we can use our assumption, right? Whenever a number is bigger than b, a is smaller than it, right? So let me use a different color. So no, this is for all b1, right? So whenever a number is bigger than b, a is smaller than it. So by assumption, a is smaller than a plus b over 2. Okay, now this is so why is this an issue? Or sorry, let me say smaller than or equal to.
What do you mean by assumption?
Blue underline.
Yeah, I thought assumption is A is bigger than B.
So remember, the assumption is whenever a number, this is for all b1 bigger than b, right? So a is smaller than any number that's bigger than b. In particular, I'm saying we just said this number is bigger than b, right? So by the assumption, a is smaller than or equal to it.
Yeah, I was just confusing about the assumption in the problem or by ourselves.
Oh, okay. So this is saying for any number bigger than b. So they called the number like b1. A is less than or equal to it. That's the assumption. That's what the blue underline means. So I guess, yeah. So if you don't like B1, you could change it to like C or something. Show if A is less than or equal to C for all C bigger than B. Yeah. But I just wrote B1 because the book uses B1. So okay. So using the assumption, like we have, so here we have a number that's bigger than b, right? We just said a plus b over 2 is bigger than b. So using the assumption a is smaller than or equal to it. But then if you subtract a over 2, you get a over 2 is less than or equal to b over 2. And if you multiply 2, you get a is less than or equal to b, right? So we get a contradiction because we assumed A was bigger than B. Yeah. So is everyone clear with this?
Wait, how did you get that by assumption A is less than A plus B divided 2?
So which part?
The part beginning with by assumption.
Okay, so right here.
Yeah.
Okay, so okay. Let me put it this way. So we have that A is less than or equal to C for any number that's bigger than B. Yeah, this is the assumption. Yeah, it's right here. Yeah.
Mm-hmm.
Okay. Now we showed right here that this number, the number a plus b over 2 is bigger than b. So using the assumption, I'm taking my c to be a plus b over 2.
Okay.
So a is smaller than or equal to a plus b over 2. Does that make sense?
Oh, yeah.
Okay, okay. And then we get a contradiction. So yeah, so hopefully that you know answers all your questions. So I normally leave like a lot most of the time I leave like the last 10 minutes for like homework questions, but let me explain the quiz first. So quiz. So again, it's on Thursday. So I'm going to tell you what the questions will be on. So Thursday. So I'll upload the file at around like 2 p.m. right? So I think I set it so it's due by like they didn't let me put 12 a.m. So I had to put Friday 12:01 a.m. So you have like an extra minute. So basically you have like 10 hours and 1 minute to do the quiz. Though again, the quiz should only take like I'd say 10 to 15 minutes max. Yeah. So I'm saying like even if you finish, like make sure you check the time it takes you to finish, right? Because if it's taking you like an hour to do the quiz, you're probably not gonna finish the midterm because I don't think the midterm will be, I don't think you're gonna be given like 10 hours to do the midterm. So okay, so question 1 will be an induction problem, right? So basically I'll ask you to prove something using induction. And then the second one is I'll give you some number. Give you some number. And then your job is to show it is not rational. Yeah. So there's 2 questions on the quiz. So
on the canvas, or how do we do it?
did you do quiz 0?
No, because I just added the course, so I kind of missed it.
Oh yes. So what happens is there's an assignment tab, and you would so what you do is first you go to at like 2 p.m. you go to the files section, and then you hit quizzes, and then I'll upload the quiz questions there. And then what you do is you just get a piece of paper, you write down the solutions, and then you upload it to the assignment tab as a PDF. So basically you write it, scan it as a PDF, and upload to Canvas.
All the things we have to do within 15 minutes, including the scan and
No. So I'm saying the quiz should only take, but you have from 2 o'clock p.m. Thursday to 12:01 a.m. So you have like 10 hours. Yeah. So I'm not saying you should take 10 hours to do the quiz. Okay. So the only reason I'm doing this is because like daytime in US is like nighttime in China. So like I don't want you to wake up at like 2 in the morning just to do a quiz. So I'm giving you this time interval to so everyone has some point in time where it's reasonable for them to take a quiz.
So 2 p.m. is US time, right?
Yeah, so Pacific time. Yeah, Pacific. So you could think of like UCI time.
Okay.
Okay. Yeah. Yeah. So hopefully 10 hours is enough, right? I mean, you have section on Thursday, right? From 5 to 6. So okay. So any questions? If not, I'll leave the remaining 10 minutes for homework. So yeah. Okay. Thank you.
已经